Welcome to the cockpit talk of Automobilwoche, this time here right from the center and the heart of the automotive industry in Munich. My name is Angelika Suri, I'm your host, and as you can see, my guest here is standing right next to me. I will introduce you now in a second. We are going to talk about the topics today about the software-defined vehicle, and we are focusing also on the over-the-air software updates as well as on the homologation and its challenges. For this, I have my guest here who I want to introduce to you now. This man, he has a PhD in economics and he has held various senior global sales roles in the industry. So since 2020, he switched to T-Systems International GmbH, and since then he is responsible for well-known customers such as Daimler, Volkswagen, BMW and Tier 1, just to name a few of them. And as you can see, I have a present for you. So I want to introduce the Senior Vice President Automotive at T-Systems, Dr. Christian Hort.
Hey, thank you, Angelika. Very, very nice. I really do like the mascot of the IAA this year. My kids will love it. So thank you for that.
And
I think it's a squirrel, right?
It's a squirrel, right, and it also has the IAA logo on it.
That's very nice, and I think a squirrel is really good in flying, so we send you away, buddy, for a few minutes and then take you back. So a nice fly. Welcome, great catch.
So let's start directly with our topic, software-defined vehicle. You are at T-Systems, and T-Systems is the IT provider in the automotive industry in Germany for over than 25 years now. So I guess you're also knowing what are the key IT trends which are also driving the transformation in the industry. Maybe you can give us some insights.
Yeah, thank you, Angelika, for giving me the opportunity, and thank you for having me here. Look, we're talking with our customers about many trends, and if we focus that a little bit more on the product, the car per se, yes, we talk about artificial intelligence, how this is facilitating our life, how we can code faster, how we can test the code faster and improve the feature increase in the car. But we're also talking with all the partners in the automotive supply chain about how we share precious data very efficiently, that everybody can access the data he needs in order to have a much better resilient supply chain. That's Catena X, where T-Systems is one of the lead investors. And I'm a big fan of virtual development. We put with our customers entire factories in the cloud to simulate further procedures in the future, further products which can be built in these factories, but also in the algorithm development, we are working a lot with virtualization, and there's a lot to come. That's my most favorite trend.
Mm-hmm. So there are two trends right now in the automotive industry. One point is the decarbonization, and the other one is the software-defined vehicle. So the good thing about the software-defined vehicle is that the software can always be updated on the vehicle, but maybe you can tell me a little bit more. You have gained a lot of experience in this field. So what is the state right now about the software-defined vehicle, and what are also the challenges about it?
Yeah, thank you very much. I think what's the state of the software-defined vehicle? It's a long journey. While we reach a certain maturity with elements that we do have the capabilities more or less together, but there is a significant increase coming how we are simplifying the whole processes, how we're maturing the processes and increase in a much shorter period of time the features in the car by regular updates. Not constant updates because that's very costly, but at regular updates in the car to enhance the safety and the feature with the car. And look, it feels really good to be part of Deutsche Telekom, you know, our big mothership.
You have a great network.
Exactly, yes. Because that's the base. You're so close to the heart of connectivity, because connectivity is the essence. Without connectivity, no software over-the-air updates and no other functionalities. And it's a little bit of an advantage from us that we are working so close to that connectivity field, because we can build nice features by really having deep knowledge and deep insights into 5G APIs, which are important then to deliver a superior service. And with our customers, we are talking about how to predict the software updates, because that's also essential to understand at which moment in time in the future you need to reserve which bandwidth where globally. Mm-hmm. And this can be perfectly done with our colleagues from Deutsche Telekom. You reserve the bandwidth in the future and you make a good contract in advance and save a lot of money.
So one aspect is also that we're having the over-the-air software updates, but the problem, I say, is that if it comes to safety-relevant driving functions, it's very difficult to update the vehicle if it comes to this. Why is that?
Yeah, one of the major reasons is that the algorithms for safety-relevant functions need a lot of time to be developed. So the engineers are developing the algorithm. The algorithm needs to be validated and tested. It needs then be approved by the authorities, and that has been done in the past with a very long-lasting process with a lot of stations and points in between which need to be there as a documented checkpoint. And that's something we are going to accept as a challenge and change this. We are going to change this process to be much faster with the approval process and allowing a higher frequency of safety enabling or safety enhancing software in the car.
Mm-hmm. So maybe you can also explain the difference to me. What is the difference between simple software updates and firmware updates?
Those are very technical questions, but
for everybody who is not into technique, maybe you can explain it easy.
Maybe I give you a few examples. I mean, it's probably not very precise, but broad categories, right? Easy software updates are probably, or more simple software updates, if you change a color pattern in the car on the HMI of the infotainment system, or you change the algorithms, how you replay audio, you change the audio setup in the car, or you add a new media player into the systems. All of these are technically still very, but not deeply ingrained like firmware updates. A firmware update is something which is entirely closed to the tied to the hardware, and therefore you require a complete different sensitivity, because if something is failing on a firmware update, which is part of a larger system, if that component has a problem, it is certainly affecting the larger system and can lead to the whole to entire breakdown of the car. But for our topic, it's more important to differentiate between type approval relevant software changes and not type approval relevant software changes. Type approval changes are changes which are affecting the regulations which are mandatory to have the approval to allow the car to be on the road. It could be changes in the system which are affecting the CO2 emissions, for instance, which are affecting the powertrain, but also, of course, everything which is related to safety, and there are a few more criteria. It sounds easy to categorize them, but simple changes in one area of the software can certainly affect other parts which are then relevant for type approval. So we put in quite a lot of effort at the beginning of the software development planning to differentiate and clearly determine what's type approval and what's not type approval.
Okay, I understand. So also if it comes to wait a second. Okay, so also if it comes to simple software, this is more like the entertaining aspect for the customer maybe, and also the other part, the firmware update, this is like really the heart of the car. You need it for the car so you can use it, right?
Yeah, that's correct. I mean, both of these updates are somehow relevant. One is more for the end customer, that you have enrichment of very easily perceivable features. And the other part is more from a technical perspective, that the whole system is working according to the specification and that is operating safely. And therefore you have to always differentiate what you will perceive as an end customer and what is system relevant. And most of these updates are not immediately perceivable by the end customer. Most of these updates are deep in the system to assure that the system operates in a fresh mode, which is then more safe, more secure on the road.
Mm-hmm. So also for me now as a car driver, also the situation is changing. What does it mean that the software is also included now in situations which are sometimes safety critical? What does it affect, or how does it affect me as a car driver?
I mean, once the car is on the road, let's start with that moment. The car is on the road, it has a certain setup, there's a certain state maturity of the software, a certain release of the software in the car. So the question is right now, how can we evolve the capabilities of the car into the future? Just to give you a few reference points. And by the way, everything I'm telling you right now is under the firm assumption that the hardware in the car has the sufficient carrying capacity, that you have the right sensors, that you have the right compute, which is sufficient for the future algorithms, because that's the prerequisite. You're not going to change the hardware. That's why we're decoupling hardware and software, focusing on the software right now. Just if you pause a moment today and you rewind 7 years, what you saw 7 years back as SOP was quite different. It really feels old. Now fast forward 7 years, and you will see what kind of changes you will experience in the same car. I'm telling you this because that 5 to 7 year period is the golden moment where the industry is intending and still can update the car. Afterwards is pure maintenance. Right? The auto industry is calculating 15 to 20 year maintenance of the whole car, and then there's a moment when that makes no longer sense.
Okay.
I mean, for us as end users, 7 years appear long, but this is why I shared that comparison with you. Just think about what was the greatest feature 7 years back.
I even can't
and you
remember.
Don't, exactly, well, exactly. And you don't know what you're going to see in the future. There will be massive changes.
Yeah. So you think in the next 5 years there's more to come if it comes to software-defined
Absolutely,
vehicle?
and the only way how we can put that in the car is a really resilient over-the-air software update methodology, but also a full digital process to keep the compliance in place. And this is why we're working together in the consortium to exactly address and tackle that huge challenge in the industry.
So if it comes to software-defined vehicle, also data is the heart of the software. Maybe you can explain to me what role does data play for you at T-Systems? How are you dealing with data?
I mean, it's definitely the most important part of the whole ecosystem we are talking about. And just to give you a few examples, if we develop ADAS algorithm, you need really tons, petabytes, how we say that, petabytes of data. These data need to be captured first. They need to be brought into the cloud out of a large fleet, and then somewhere put in the right repository to be able to really support the development of the algorithms. And it's always a debate between where do I store the data? Should I put them in the cloud? I think at the first moment, yes, that's very reasonable. And if you operate the data, then there should be on a system which is close to the algorithm due to latency reasons that you have a fast data reply. But all over the place, data is super important, and T-Systems with a very long tradition in managing large amounts of data is very well positioned. And let me also share that all our data centers where we conduct the compute, where the action happens, will be green until 2028.
Wow, so in 5 years from now?
Yeah.
Okay, that's amazing.
That's very good because it's a very strong contribution to the whole sustainability story in the automotive chain, that we also, as IT companies, are entirely green.
Mm-hmm. So we've talked now a lot about the software, and I know you have a car right at the test drive. Maybe we should check it and go there.
Yeah, absolutely. Let's walk over there.
Awesome. Christian, before software gets installed in the car, it must be tested in many traffic situations. How does the process actually look like?
Yeah, that's a very good question. Let me start with the old world, how it happened, as we technicians say, in the old days. The software, the algorithm had been developed, and after a certain maturity state, the software is then be downloaded and installed in the vehicle. And then the test drivers became clear instructions which scenario to drive. And then any anomaly, anything what happened, you had a lot of cables in the car, you logged the events, you came back to the garage, and with all this new information, the engineers improved the software. And a few days later, the same test drive continued again. So this is an iterative process which took a long time. And that's the reason why we today base our approach on new technologies like virtual homologation or virtual validation, which is speeding up that process significantly. Let me tell you how this works. So two essential elements. You have the algorithms on a server farm, and you have a virtual ground truth. This is how we call it. This is basically an artificial world which is created by software. You are driving the route we are seeing in front of us, you record it with all sensors, and you move it into a virtual world. Now the beauty is that you can change the situation on the road very fast. I mean, it's exaggerating a little bit, but almost by a click of a button, you can add cars, you can change the speed of the cars without driving new mileage out there. And this is the reason why it's super cost efficient, and it speeds up the development process massively.
Mm-hmm. So after we have done all of this tests in the virtual reality, and let's say the software is truly safe and it's ready to go, what would you say, what will be the problem if it comes to the vehicle fleets, if they need to be updated, because it could also happen that, for example, the original type approval might be expire after all of the software updates. How can you solve this problem?
I mean, that's exactly the key challenge of the industry we are solving with a lot of partners right now. First of all, the decision is after you change a feature or you have a regulatory change which requires a change of the software, you have to decide if that is type approval relevant, yes or no. That's the key decision. Once that is type approval relevant, you are going with the whole development and validation process on an entire different route. And in that process, we are validating with the new technologies in a very efficient way the maturity of the software and the stability of the software, that the authorities can base their decision on a fresh new evidence in order to have a very compliant process in place to grant the new type approval. And that's the essence of the whole work we're doing here, and hopefully we can solve it for the industry.
So Christian, let's say the automaker is convinced that the software is now safe and ready to go, and in the theory it could just be updated on the vehicles via the over-the-air software. But the problem could be, for example, that this could also include some changes if it comes to the original type approval. The original type approval could, for example, expire. How could you save this problem?
It's a very good question, because that's the central point why we're here all together today. First of all, we have to decide if that's type approval relevant, but let's assume yes, that's a change in the software which is affecting the type approval. So we need to run that new piece of software, the delta part, the incremental change, in a validation process, which is then clearly showing that the software is doing what it is intended to do, that is fully compliant and completely validated. And once that is done, including the documentation, we hand that over to the inspection authorities, which can then double check if the methodology, if the process, and if the outcome, the result, is according to the regulations. And with this confirmation, we've sent this whole package to the authorities, which do then decide, based on all of this evidence, yes, we are really confident that we can issue a new type approval. So the catch is that the whole process needs to be super fast, because we will see in the future a much higher velocity and frequency of software updates as we all working towards more safer cars and more features in the car. We need, as a whole team, as an industry, work towards that challenge together.
Okay, I feel the car is ready to go. So we talked a lot about the over-the-air software update. Maybe you can show me now a little bit as it is in practice.
Yes, we will do so, and let's get it going. Thank you, Angelika. So Angelika, hi. So we're at the car right now. So we are fully prepared for our test drive.
I'm very excited.
I can see it so fast. Safety belt all buckled up. Very good. Look, what's going to happen is, first of all, I'll tell you a little bit what you see in the car. And let me start with the screen you're seeing here. Mm-hmm. That's a system which is overseeing the behavior of the car during the ride. Okay. And that's a translation of the legal requirements into boundaries in which the car needs to prove that it's operating according to the legislation and according to the regulations. Mm-hmm. So we have a run of 2 steps. So the first step will be that we drive towards the car there, activating an automated lane keeping system until 60 kilometers per hour. And the car will stop according to the regulations in front of the car. Then we will come back and also show you a little bit more what the system is capable. Khalil will do then that part. Mm-hmm. And then we come back again and get an update over the air into the system, which is enhancing the capability of the algorithm. So the technicians say we are enhancing the operation and design domain of the car. That means the car is capable to bypass the car, and also we are increasing at the same time the maximum speed of the car. And that would be the full demonstration of how the over-the-air update, according to the regulations, including the homologation, works.
Okay, sounds great to me.
Very good intro. Yes. And one comment, I'm not allowed to drive the car. I did a lot of talking to Kali, but Kali said you stay buckled up on the passenger seat, and this is why I happily hand over to you, Kali, right now.
Professional safety driver.
Thank you.
So we'll now start the ride up to 60 kph without lane change. Be ready. System is on. Lanes are detected. The front car is now also visible on the display.
And this is all live, right?
Exactly, with live data. And we should hopefully stop behind the car. I'm not doing anything.
Okay, it works. That's good.
We are still there. I'm now taking over manually.
So that was the first phase of showing that the existing algorithm, which has been already installed in the car, is working properly.
That's good.
Right. And what we're doing right now is a little bit of showing that how the sensitivity of the system works if we are violating one of the key KPIs of our operational design domain, in this case the speed of the car. So that's pretty impressive because everyone down the road will always get a little bit scared then. But Kali,
We now exceed 60 kph and the first box here will turn to red.
Okay.
Here
Yes,
it is.
now it's red.
you can see how they're moving. So that was a demonstration that the systems is always overseeing if the algorithms is working according to the specification and within the boundaries of the regulation. So once that is happening, the car would definitely violate the approval if it's driving on its own. But in this case, we did it manually to prove and show the capability of the monitoring system.
So we could see it always reacts to everything what is spontaneously happening. So for me as a driver, this is like a safety aspect.
Exactly. Also more in a sense that we are constantly proving that it stays within the regulations. I mean, the system which is responsible for your safety is the system which we are monitoring. So those are the colleagues who are developing the ADAS algorithms, and they also developed the next stage of the test drive, in which we are going to show that the software, which Khalil is right now will then initiate, is capable to do more. So it's capable to see the car and then bypass the car in the full ride, and that's the expansion, including the increase of the maximum speed. So I think this is what we're going to show right now.
130 kph on the test ride.
Awesome.
So lean back and enjoy.
Yes.
This time we'll perform a lane change. So let's start the system.
So again with 60 km.
Right.
Okay.
Well, we have now the system which is the ALKS 130, so according to regulation we can drive up to 130 and perform a lane change. On this test track we will reduce the speed. You can see the turn indicator is on autonomously. I've done nothing.
Wow.
We have overtaken the car and I will of course take back the control because we have no lines anymore and we are arriving at a dead end.
Amazing.
As you remember, we have exceeded 60 kph on the first way back. Now the maximum speed is 130. Let's try again.
Okay.
We won't reach that speed, of course, but I will exceed 60 and the road is this time not broken.
So that's the second proof. You saw the maneuver, but you saw also that we could drive the car much faster back, and this is showing how we kind of expanded.
The update worked.
I mean, for everyone, very perceivable that the algorithm is more capable. So that's a cool part of it.
Wow. Thank you very much for showing us in practice. So Christian, you have developed with your partners the process, the so-called virtual homologation. How does it work?
Yeah, so every good demonstration has, of course, a high-level architecture view in PowerPoint, and that's the mother of all charts. This is what we're seeing here. So how does it work? It is a continuum of several process steps which are nicely tied together. And let me start also a little bit explaining what each of the partners is doing with the rules and regulations at the beginning. So it could be a regulatory change, or our OEM customers do enhance a certain feature, and our partner control is scanning globally the prerequisites and the regulation in countries, and it's translating then these regulations in rule-based systems which can then be processed by algorithms. So that's the first key important step. And then once the requirement engineering is done, the partner, in this case FEV, who is developing the ADAS algorithm, is then engineering according to the requirements the algorithm, and once that has reached the right level of maturity, it's handed over into the validation and simulation, which is done entirely virtually. And that's a very important part, And this entire domain is provided by DSpace. And DSpace is providing the theoretical artificial ground truth against which the algorithm is tested, validated, and then at the end, at a maturity level with all the evidence acceptable for the institutions which are then providing the certifications, which is in this case TÜV Süd. And TÜV Süd is reviewing the whole process and methodology of the validation, but also the results. And once that entire package, I'm cutting a little bit through the chase here, is completed, it is handed over to the KBA, to the authorities for issuing the type approval. Once that type approval is received, the systems technology with all the over-the-air capabilities is then assuring that the software is properly deployed in the car and that this is it's done in a way that is really doing what it is supposed to do. And in order to have this whole continuum up and running, we have many other partners. Microsoft is our technology partner for all the cloud computation, also the software development process. We have Barrels here for the PMO part, helping us to change also the organizations at our customers, because the whole process is a new process for everyone, and therefore you need also from a cultural perspective to conduct quite a few changes. And if you see what's remarkable is, as I walked you through the whole system, it's a strong collaboration of multiple partners from different areas. It's not just tech partners. We have large tech companies like Microsoft. We have IT veterans like T-Systems. We have a top management consultancy with Barrels. We have one of the leading engineering companies, one of the leading simulation validation companies, and all of them work together with a TÜV as a certification authority, as an example, and also finally with the institutions, with the KBA. And the essence is we all need to provide enough evidence that this process provides the maturity and the stability and the resilience that it can be accepted as key evidence to allow new algorithms to be type approved and then be fast in the car. So that's the essence of all what we're doing here today.
Wow, that's very impressive. So as we're at the end of our talk now, maybe you can also give us some insights. What is next to come at T-Systems? Maybe you can tell us some goals for the future.
Yeah, absolutely. So it's a pleasure. So we're definitely investing a lot in how we can speed up the development process for the end product, and we will definitely enhance our capabilities and our customer experiences in terms of how we provide the underlying services for our customers, that they can really focus on where they're really good at, which means building features which are differentiating in the market, which are increasing the safety. And this is why we are, I think, a very welcome partner in the whole system to assure that the entire IT infrastructure with all our partners is up and running smoothly. And there's a lot to come, because all the virtual work we're seeing today is requiring a lot more IT knowledge, a lot more compute. And this is why you can clearly observe there are more IT relevant or IT heavy partners in the game right now.
Awesome. Thank you very much, Christian, for your time, all the insights, and also the adventurous test drive.
Thank you, and I see you enjoyed it, and it was also a pleasure. Thank you for having us here. Thank you for having me in person. I'm looking forward to the next talks. Thank you, Angelika.
Me as well.
Pleasure. Thank you.
Dr. Christian Hort from T-Systems. That's the end of the cockpit talk, this time from the IAA Mobility 2023. So stay tuned and take care until next time. Bye-bye.